Okay, dear students, let us see this question. A positively charged particle moves parallel to a wire that carries a current in upward direction. What is the direction of magnetic force on the particle? Okay, fine. So as I have told you that instead of Fleming's right hand or left hand rules, I try to use right hand palm rule as it is mentioned on your screen already. So right hand palm rule is of three types: type 1, type 2, type 3. And type 1 is used to find the direction of magnetic field as produced by an electric wire. So we would be using this law here, and in the second law, which is finding the direction of the force on a moving charged particle. So these two laws, both of these laws are required to be used here to find the actual force on the charged particle. Well, the third type will be used in the case of induced current, and that is not the case here. So we are not going to discuss that. So type 2 is clearly written on your screen. That is, fingers are pointing towards magnetic field and all that. We will see it. But type 1 is not written. I'm sorry for that. So I'm writing type 1 now, finding the direction. So we are using our right hand now, and we point our thumb towards the direction of the electric current in the wire, and we point our fingers towards the point, okay, towards the point where we want to find the magnetic field. So in this case, the current is going upward, so we are keeping our thumb like this and we keeping our palm like this, and it has to be right hand. So the current is moving upward and I'm pointing towards right because your charge is in the right direction from the wire. So I'm pointing it towards like this. It's like that. So my palm is pointing towards you. So my palm is pointing towards you. My palm is pointing towards the laptop screen. So I can say that there will be the magnetic field which will be pointing towards into the plane. I will say the magnetic field is going into the plane. So the magnetic field here is into the plane of the paper. Now, so this is type 1 we have applied here. Palm will show you the direction of magnetic field. We have found the direction of the magnetic field on the location of the charge. Now we're talking about the charge itself. So we are now considering the type 2 of the right hand palm rule, which will be used to find the direction of force on the charged particle. So what do we do now? We are again using our right hand. So what are the given things? The velocity vector of the charged particle, that will be on thumb, and magnetic field, our fingers will be pointing towards magnetic field. So magnetic field is into the board, so magnetic field is towards you. From my side it is towards you, so I am pointing my fingers towards you, and the charge, positive charge, is moving in upward direction. So my palm is now pointing towards the left side. So it means the charge will be experiencing a force in this direction. The charge will be experiencing a force in left hand side. So according to our options, A is to the left, B is to the right, into the page, out of the page. So our answer is the charge will be experiencing force towards left. Let us verify it from the mark scheme, and yes, the answer is A. So in this question, I would like to tell you that I am not using Fleming hand rules. Instead, we are using right hand palm rule. You can search for these things on internet also, and you can watch my video again and again. You can try this question, doing it again and again, and learning the right way to place your hand properly, and then it will be very quick and very effective for you. So this is the best method of finding the directions in magnetism. So with this, all the best. Why?